So hello everyone, this is another geological map interpretation exercise, and in this exercise, this exercise is different from the exercise that I have already uploaded. So from this exercise, you will learn something new. What is going to be happen within a basin? Okay. So if we look at this map, we're getting B, C, D is also the A, B, C, D, and there is one fault. And this side of the fault, we're getting the same setup A, B, C, A, B, C, but in a folded pattern. Here we are not getting like that, okay? So, and then we are getting F, G, H, okay? So now we have to find out that, and one more thing is that if some beds are covered by some other lithology, no? Okay, so then we have to look at those lithology first, okay? Like FGH is covering these ABCD lithology, okay? So then our first target is this, okay? Either these beds are horizontal or not, okay? If we look at the contour, these contours are parallel with the body boundary or strata boundary, okay? So it means our FGH are horizontal, okay? Now we have to look at this part, okay? There is a fault, we have to look at this part separately and this part separately, okay? So now we find out the dip of these beds, okay? Here we are able to find out that this is our 300 line, okay? We have to choose those points, those contours which cut the strata boundary at two places, okay? Those are our strike lines, okay? This, okay? So this is our, oh sorry, I'm cutting the same boundary, okay? Okay, now go with this, okay? This is our 400, this is our 300, okay? So beds are dipping like this, okay? This is our 300, sorry, 400, and this is our 300. So from higher to lower, okay? We can use this also, okay? If we extend this, okay? Okay, this is our 200, this is our 300, okay? All of them are dipping in the northeast direction, okay? And a similar way we are getting this here also, okay? So this side of fault, western side of fault, we are getting all strata dipping toward east, okay? So now if we look at this part, okay, and this F, G, H are horizontal, and we have to look at this part, okay? If we look at this part, this is our 400 line, this is our 300 line, okay? This is our 300, so 400, and this way we are getting beds are dipping toward this side, okay, west, and here we are getting beds are dipping toward like this, okay? Now if we look at this part, this is our 400 contour, and this one is our 500 contour. So it means these beds are dipping toward this. We have to draw perpendicular, okay, on these lines, okay? But if we look at the spacing, okay, spacing between the two lines, these strike lines. Okay, we are getting almost 1.3 and almost 1.3, getting 1.3. Okay, so this part is dipping this way, this part is dipping this way, and obviously this part is also dipping this way. Here we are getting the two contours. Okay, this side we are getting dipping this way. Okay, and after that we are getting again started dipping this way. Okay, so and the spacing is same. It means, and if we are able to find some other things apart from that, okay, here we are not getting such type of scenario. We are only getting the strata dipping toward east. Okay, here we are getting west, east, west, east. Okay, so it means this is our fold axis. Okay, here we are again getting a repetition of strata. This is ours A, B, B, C, C. Okay, and all are dipping this like this. That is dipping this way, this is dipping this way. Okay, at this place. So it means this is our fold axis. Okay, and if we look at this part is dipping this way and this part is dipping this way. So we are getting a syncline. Okay, we're getting here syncline. Okay, so here we are getting anticline, syncline, again we are getting anticline. Okay, so in this way we are getting so it means this part is folded. Okay, either this part is folded or not, we will have to look. Okay, now is there any other folding that we can observe from this? Okay, if we look at this part, this is our 500 contour, this is our 500 contour, this is our 400 contour, cutting the same strata boundary. Okay, so this is our 500 contour, this is our 400 contour. It tells us it is dipping toward this side. And if we look at this side, so we are getting this one is our 400 contour, this one is our 500 contour. So it is telling that it is dipping this way. So it means area is suffered by two deformations. Okay, one deformation is like this. If we construct this, we are getting a syncline like this. Okay, because data is dipping toward this now, so it is a syncline according to this folding. Okay, syn form, we can say, I can say it is a syn form if we don't know the which one is the older, which one is the younger. Okay, in this way we are getting like this. And if we look at this side, okay, I'm not able to find any other this kind of setup where I can find out that where it is dipping. So it means all are dipping like this. One major syn form is there. Okay, in the east extraction, and this is our anticlinal axis. Okay, in this way we are able to identify that this part of the eastern part of the fault is getting superimposed folding. Okay, so if we want to visualize the things in 3D, okay, I will show you those things. Okay, this part is dipping, this part is dipping this way, this part is dipping this way. Okay, and if we look at this part, is dipping this way, and that part is definitely dipping that way. Okay, so we are getting a folding like this. Okay, and here this part is dipping this way. So if I after making this, if I compress it like this, no, compress it like this, so this part is dipping now this way, this is dipping this way, this part is dipping this way. Okay, in this way we are interpreting our map. Okay, this is a 3D view of the area. Okay, so this one is our one fold axis. Okay, this one is our one fold axis, and these are the other fold axes. Okay, which one is F1 and which one is F2, if it is possible we can interpret. Okay, if it is not, but we are able to try to find out that areas suffer from two phases of deformation. One is from north south and one is from east west. Okay, and after that these beds are deposited over it. Okay, that FGH. Okay, and before that this fault also took place. So now if we look at this part, okay, this side strata is dipping this way in the direction of the without plotting the cross section. I am telling you which one is the older one. Okay, okay, we need not to do all those things. If someone asking us to interpret this map, just looking at the map we are able to tell that this is the setup. Okay, so this strata is dipping this way in the direction of the dip. We are getting the older rock, younger rock. Okay, so it means our A is older, B is younger. Okay, so we are getting a in the core, because this is our anticline. If you look at if the forces are applying from this. Okay, so we are getting a core, older rock in the core. Okay, and the limb we are getting the, as we are moving away from the core, we are getting the younger rocks. Okay, and this is our syncline. We are getting the younger rock in the core. Okay, and older rocks away from the core. Okay, in this way we are interpreting. Now this is one more folding took place from this, and overall it is like this. So this is one more fold axis. Okay, but this side we are not getting any folding. Okay, but the beds that are present here, the strata that are present in the western side of the fault, we are getting the same setup here. Okay, so what kind of scenario it is? Okay, and we'll draw a cross section for this, so that I will draw a cross section of it. Okay, so that all the things should be clear. Okay, so I will select a line like this. Okay, XY. Okay, and this fault is dipping in which side, if we want to, because the fault is not straight, so we are able to calculate in which side it is dipping. Okay, this contour is 400, this is our 300 contour, so this fault is roughly dipping toward west. Okay, from that, and we can calculate the dip amount. Okay, true dip and as well as apparent dip. Okay, if we want to go with the true dip, so we have to draw the strike line perpendicular to this. Okay, the dip that we can get from this, we can use it as a true dip. Okay, but if we are plotting a strike like this, then we have to calculate the apparent dip. I will tell those things in the other videos, okay, how to calculate that rho dip and other things, okay. So in this video we know that this is our scale and we have to measure this with our scale. So it is 2.5 centimeter and it is equal to 500 meter, and 1 centimeter, it means it is equal to 200 meter. So in this way we can calculate this distance. This is approximately 1.3. This distance everywhere I'm getting 1.3, okay. So vertical distance is 300 minus 400, it is 100, and the horizontal distance is 1.3. So it means 1 centimeter is equal to 200, so it means it is equal to 160 meter, okay. And if this is alpha, we can calculate, okay, 100 by 160 is equal to tan alpha using Pythagoras theorem. Okay, this way we can calculate, okay. The dip is not changed, okay. So now we have to draw the this is our x, this is our y, okay. After looking at this cross section, you are able to interpret more, okay. And this is our 200 contour, so this is our 100, this is our 200, 400, 500. So this is our 200 contour, this is our 300 contour, this is our 400 contour, and we are getting the 500 contour. So in this way we are going. This is the setup of our, okay. Now I'm going to mark the beds of this line. This is our fault. Okay, so this strata is dipping this way and this fault is dipping this way, no? It is tree fault, okay. And this strata is dipping toward this way, toward our east. This is our A, this is our B, this is our C, this is our D, okay. This is our fault, okay. And we look at this part, this strata is dipping toward this side, okay. And if you look at this strata, it is dipping this way. Okay, these two strata are drawn, these two, now this, and this is dipping this way, and this is dipping this way, and this, after this we are getting a horizontal strata. Okay, this is our F. I have to draw in that way so that all lithologies will cut, okay, and all those things will come over it, okay. F, G, H, okay, if it will come, if I will draw a cross section like this, okay. So now this is our A, B, C, D, and here we are getting again A, this is B, this is B, okay, this is C, this is C, this is C, and this side we are getting again, these lines are D, and we are getting C. This is D, this is not D. Okay, this is D. Okay, A, B, C, D. Then again we are getting C. So this is 500 contour, this is 400 contour. Sorry, this part is also dipping this way. Okay, it is dipping like this. Okay, A, B, C, D. Then we are getting C. Up to this much we are getting dip like this. Okay, but if we look at this part, there is a repetition of strata. It means these are dipping this way. Okay, this strata is not dipping this way, it is dipping like this way. We are getting D here, and this whole part is C. Okay, so it means it is, and here if we construct it, a similar way it will go like this. Okay, and this part is our D, this whole part is our C. Don't confuse. Okay, because I have marked it wrongly, so that's why it's happened. Okay, and here we are getting this type of scenario we are getting from this picture. Okay, this is our anticline, this is our syncline. We're getting D in the core. Okay, and if I want to draw the cross section like this, we are again getting folding from that side also. Okay, this is a symmetrical folding. Okay, from this side and this side. In the core we are getting the older rock, here we are getting the older rock. Okay, so this part of the fold is okay. So now which part of the means if we look at this fault, so we are getting the same setup here, but this part is folded, this part is not folded. Okay, so we are getting the strata, highly deformed strata. Okay, instead we are getting the same strata, but it is not deformed. So in this way we are tell here we are getting two set of deformation, here we are getting only tilting of the block. Okay, no deformation, only tilting of the block. Okay, within a basin, some part of the area basin is got two set of deformation, and due to faulting, the part that is not folded will just come adjacent due to faulting. Okay, so in this way we can say that this part is we have to infer this part is going down, this part is going up. Okay, so we can say that this is a normal fault. Okay, and we can also interpret that it is a reverse fault, because as such data is not available. On the basis of that, we can interpret that it is a reverse fault or a normal fault. Okay, it is difficult. I know that this fault is dipping toward west. Okay, I know that only, but I don't be able to interpret. Okay, So hope you learn something from this video. Try to share this video with your friends so that they can also get the benefit. Thank you.